Let's get it started. Okay, guys, welcome to the day 7, and today we are going to deal with what? This cast algorithm, right? The shortest path finding algorithm that is most popularly used, apart from its counterpart that are Floyd Warshall and Belmont. You will be using this Dijkstra the most. Okay, so without wasting any time, let's get to know why this Dijkstra. Okay, first thing first, why not DFS or BFS? So the short answer would be DFS goes in depth too much. That is not required. It increases the number of calls, the call is in the stack, and it is not suited because it goes in the depth. Because the answer would be lying in the breadth instead of the depth. So that's the thing. And I've already explained this particular thing why DFS is not suitable. So that's why I'm not explaining it in this video. I've explained it in my first video, in the second video of the graph series, where I talked about why DFS and BFS work differently and in what kind of situations we should prefer DFS and BFS. So there's no point of explaining DFS, but there's point of explaining BFS because, as said in that video, BFS is suitable for finding shortest path in a graph, right? So why not BFS? Okay, so why not BFS? Let's see. Let's first create a graph for this particular thing. We have node A, we have node B, and what is the distance between them? Let's just say it's 2. From node A, we can go to node C. The distance is 4. From B, we can go to C at a cost of 1. And then finally, we want to go to D. Okay, what is the cost till D? Let's say 7. Okay, great. Now, to do a simple BFS, the first thing first, what will I be requiring? So first thing first, what I need to find is a shortest path from node A to node D in this particular graph, right? From node A to node D, I want to find the shortest path. So for that, I would create a simple queue and start my BFS. So initially my BFS will start from node A, which is pushed in the queue, and when I pop this particular node out, I won't be knowing the distance, right? So for that particular thing, I would also create one more thing, that is our distance array. Okay, so this array is called distance. Let's just name it distance. And this particular text is pretty small. No, not anymore. Right. Now, this is my distance array. Now, what I need to do is a special thing that we generally don't do in the queue, but I would be pushing one more thing in this particular case. We just first divide the distance into 4 particular parts. This is node A distance, this is node B distance, this is node C, and this is node D. Now, this distance array would be storing the minimum distance required to travel. Okay, it is the minimum distance that we need to travel to reach node A from node A, and it is the minimum distance required to travel from node A to B to reach node B, and similarly to reach node C via A, and to reach node D via node A. Okay, no, from node A, not via, from node A. Sorry, actually I have done a shift at my unpaid intern, and then it just got me so tired, and just currently making this video at 11:15. I just don't know what I'm doing. Okay, without wasting any time, let's just keep going. So I have node A, and what is the distance I would need to travel to reach node A? That would be 0. So with node A, I push 0. Okay, great. Now, doing a simple BFS, these are the two next node that I can travel. Okay, I pop this node out. The distance to reach node A is 0, and to reach node C, what is the distance? 0 plus 4, that is 4. So node C could be reached in distance of 4. What about node B? Well, it could be reached in a 2. Great. Now what? Now what? As soon as I come here, I will not pop this. I have already filled this particular thing already. So to reach B, the cost is 2, and to reach C, the cost is 4. Okay, so when I pop this particular C out of the queue, I have, okay, so what I have, this is D. So 4 plus 7, that is 11. Okay, 4 plus 7, that is 11. So what would be happening is that I would be pushing this d comma 11 in my queue. Oh, okay, great. Now I have d comma 11 in my queue. What is the distance to reach d? That is 11. Great. Now from b, as soon as I pop the node b out of my queue, okay, so what is the cost? Which is the next node that I can reach from B? That is node C. Okay, what is the cost here? 2 plus 1, 3. Okay, so update this C first thing first. That is 3. Now to reach node C, the cost is 3. Great. From node D, can we go any further? No, we can't go any further. Just pop this out. Okay, no issue. Just pop this out. Now what? We are again standing at node C. Then where we can reach again? Okay, we can reach node D again. Now what is the cost to reach D? That would be D is cost 10. Great. And update this D to 10. Great. Now we have found the minimum answer because after this particular pop from D, we can't go any further. And this is our BFS, our simple BFS. We were able to solve this particular problem using BFS. Okay, right. So what is the problem? BFS is working pretty well. Now let's again draw the same graph. We have node A, we have node B, and we have node C, and again we have node D. Okay, the distance was 2, the distance was 4, 1, and 7. Okay, so this time we will change this queue that we were using as a data structure. We will be using priority queue. Just a small change, that is priority queue. Okay, great. So we have priority queue. Instead of using queue, I'm using a priority queue. Okay, now what will happen? Again, node A. Okay, this queue was not that good. Now this is my priority queue. This is my, again I need to draw another vector. Oh, sorry, I need another thing. That is my distance vector. What I need to do is copy this, just paste it here. Okay, this is my distance, right? Initially I'm standing at node A. What is the cost to reach node A? That is 0. Okay, great. And here again we have A, B, C, and D. To reach node A, the cost is 0. To B, not known. To C, not known. To D, not known. Great. Not an issue. Okay, I'm standing at node A. Great. Now from node A where I can go. From node A I can go to node C and node B. So what is the cost to reach node B? That is 2. And what is the cost to reach node C? That is 4. Okay, but since this is a priority queue, this time we have 2 comma B in the top and then 4 comma C at the back. Okay, great. Now 2 is here, 4 is here. Great. Now again I pop this 2 out of my priority queue. Now, since I pop this 2 out of my priority queue, what I can reach? Node C again. Okay, I can reach node C. What would be happening? Since I can reach node C, 2 plus 1 is 3. We have a change. So let's just use this eraser to change this particular part. Control Z. Why it's erasing this particular thing? Okay, what I need to do is I can just uh, this particular style. Okay, what can I do is just 3 comma c can be here. So we have 3 comma c again at the top of my priority queue. Great. Now I have 3 comma c at my top of priority queue, and I will pop this 3 comma c out of my priority queue. Now since as I pop this 3 comma c as my priority queue, what I have is I can reach node D. What is the cost? The to reach the cost is 10 comma D. Okay, cost is 10 comma D. The 10 is updated. Okay, now the 10 is updated. Now, as you can see, in this particular case, what happened for BFS using a queue, or this is simply a Dijkstra. I showed you as a BFS, but this is also a Dijkstra, but I implemented it using a queue. Now, using it a queue, we took 1, 2, 3, 4, 5, 6, and 6 into 2, that is 12 steps. And here, what we have taken is 1, 2, 3, and 4, 5. 5 steps only. 5 steps only, and we have 10 comma D as answer. Now, since we are using only 4 nodes, we were able to show a small difference in the change. As you can see, we pushed C once and then updated C again. We pushed D once and updated D again. Okay, so that is 2 extra updates that we did here. But how many extra updates we have did so far? Zero. If I particularly stop at this particular moment at 10 is equal to D, this is my right answer. I can keep going forward. That is a different thing. But at this particular moment, I have less updates than my queue structure that I use. So that is why in this Dijkstra algorithm we use priority queue. And there's one more thing. BFS does not work well with directed graphs. It works with undirected graphs very well, but when it's come to directed graphs, it becomes pretty difficult to find the shortest path in a directed graph using BFS. Okay, so that's one more point that I needed to add. Okay, that is what BFS is like. Now, since I have already explained you what Dijkstra algorithms look like and how it works, it is a pretty simple algorithm. So without wasting any time, let's directly jump onto some problem that we need to solve. Okay, without wasting any time. Okay. So the first problem that we are going to solve is network delay time. You are given a network of n nodes labeled from 1 to n. You are also given times, a list of travel times as directed edges time I is equal to ui, vi, wi, where ui is the source node, vi is the target node, and wi is the time taken for a signal to travel from source to target. Okay, we will send a signal from a node is from a given node k. Return the minimum time it takes for all the n nodes to receive the signal. If it is impossible for all the n nodes to receive the signal, return -1. Okay, so we are given a graph structure and we are also given times vector where there's ui, vi, and wi, and there's an edge from ui to vi, and the cost to travel that edge is wi, and the weight of that edge is wi. Okay, and we are initially standing at node k, and then we need to send a signal to every other node in this graph, and we need to find the minimum time it takes for all the nodes to receive the signal, and if it is not possible we will return -1. Okay, that's pretty simple to understand. So in this particular question, k is 2, n is equal to 4, and this is my particular graph, and the answer is 2. Okay, let's try to see why answer is 2 first. Yes, let's see. 2 1 2 3 4. Okay, that is 2 3, and this is 3, right? 3. Okay, this is 1 and this is 4, and 1 1 1. This is the cost to travel these nodes. Okay, 1. Okay, just match this. Okay, erase it. I need to buy a tab. That's the thing. Okay, apart from that, this arrow goes 2 3 4. It goes here, it goes here, and it goes here. Okay, so this is what my graph looks like. I'm currently standing at node 2 and need to send a signal from node 2 to every other node in this graph, right? From node 2, I can reach node 1 in just a wait or time of 1. Okay, I can similarly reach node 3 in time 1. But to reach node 4, the time would be 1 plus 1, that would be 2. Okay, that would be 2. So the answer is 2 for the particular question, right? Right. So to reach all the nodes, we would take some time. Now let's say for this we have node 1 here, but again from node 1 I have an edge to node 5, and then from node 5 I have a edge that goes to node 6. Okay, right, and the time is 1 here, but 12 here. Okay, so to reach node 5 the time would be 2, but to reach node 6 the time would be 14, right? Now, in this particular case, the graph is connected, but not that connected. What I can do is connect this node 4 to node 6 again. Now, what is the cost to reach node 6 here is 1. Okay, now there's problems. behaves like Dijkstra mode. Okay, so from this particular path, the time it took to reach node 6 was 14, right? And in this problem, yeah, n is equal to 4, k is equal to 2, and we have to send a signal, return the minimum time it takes to reach for all the nodes to receive the signal. Okay, we need to find the minimum time it takes to reach all the nodes. Find the minimum time in which all the nodes receive the signal. So if we go by this case, 14 would be the minimum time since because all the node would receive the signal by 2, but this is the farthest node, so it would take time 14. But if I go from this path, it would just take 3. So 3 should be the right answer. Okay, that is a thing. Now if I do a normal bfs that I usually do, and if it goes by this path, and as soon as it will encounter the last node, it will just update it, and that would be pretty pretty bad. Okay. Okay, so this is a normal Dijkstra. It is not very tough. We just have to return the maximum time, which is the time that is the largest, will be the farthest node from our current node with the maximum rate. So that would be our answer. But let's try to solve this using a queue. Using a queue. Okay, that would require a pretty big queue. This would be a pretty big queue initially. Okay, and for that would also require how many vectors? Sorry, one vector with 6 nodes. We have one, we have two, we have three, we have four, we have five, and then we have node 6. Okay, great. Now I push the node 2. It is my starting node. To the cost to reach node 2 is 0. Great. Now at the top of my queue I have node 2, and the cost to reach node 2 is 0. The node 2 is popped out. What are the two next node that would be reached? That would be node 1 and node 3, right? Okay, so let's push the node 1. What is the cost to reach node 1? That would be 1. So node 1 would be reached in a cost of 1, and similarly node 3 would be reached in a cost of 1. Great. 3 and 1. Okay. So now let's update. The cost is 1 here, the cost is 1 here. Okay, now node 1 is popped out of this queue, and what is the next node that would be reached? Would be 5. Okay, so what is the cost to reach node 5? That is 5 plus 1. Okay, sorry, 1 plus 1, that is 2. So 5 comma 2. Okay, great. And then apart from that, from 3 we can reach to node 4. So 3 is popped out, and to reach 4 the cost is 2, 4 comma 2. Now currently in my queue. Okay, 2 here and 2 here. Great. Now node 5 is popped out, and that is 2 plus 12, that is 14, right? So 14 is a cost to reach node 6. Okay, so 14 is a cost to reach node 6. Mm, okay, just a second. Node 6, comma 14, sorry. Okay, great. Now, from node 4, we can again reach node 6. Okay, pop this out, and it is 3. So 6, comma 3, and is particularly updated to 3. Now from 6, comma 14, we can't go any further. 6, comma 3, we can't go any further. And this is my answer, right? Okay, this is what I did using a queue structure, where nothing was balanced, or I can say nothing was sorted. Everything was scrambled, and I was not picking the shortest distance at the top. Now, what if I use a priority queue instead of a normal queue? Okay, I have the same structure, and what I can do is just erase this. It allows me to erase it itself. Okay, it will erase completely, not an issue. Let's just draw it again. We have this, and we have one, two, we have three, we have four, we have five, six. At the top of the priority queue, we have node 2, the cost of 0 to reach node 2. Okay, great. And the cost is 0. Now, to reach node 1 and 3 are the next. Node 2 is popped out, And since 1 and 3 are next, what should be coming at the top is 2, and since both are 2, I would say I would put 2 comma 1, sorry, 1 comma 1, because they are just next to node 2. So 1 comma 1 and 1 comma 3. Now what? Now from 1 comma 1 I can reach to node 5, right? And it would be popped out, and the next would be 5. What is the distance to travel to reach node 5? That would be 2, right? So 2 comma 5, that is the answer to reach node 5. They just put 2 here, and to reach node 1 it was 1, to reach node 3 it was 1. Now what is at the top of my queue? Node 3 is at top of my queue. It is popped out. And what is the cost to reach node 4? That is 2 comma 4, right? Okay, 2 comma 4 again. Okay, what will be happening is next is that 2 comma 5 would be popped off this particular queue, priority queue. And the next thing is that uh, the cost would be 14 comma 6 to reach the node 6. So 14 is the cost to reach node 6 currently. But as soon as I pop this, the cost would become 3 comma 6 for this particular thing, and that 3 comma 6 would come earlier than this. Okay, so the point that I'm trying to say is BFS takes more calls than our Dijkstra algorithm, and in some cases, I'm not able to show that large of a graph, but when you will be working with large graph or bigger graph than this particular graph, this is a very small graph that I have shown here, and this is where my imagination is limited. I can't generate test cases from my mind, but this is a fact. This is a particular thing that BFS won't be working very well with large graph when it comes to find the shortest path algorithm or shortest path in a graph. That's why we have separate algorithm to find the shortest path in a graph. Oh, so that was my point. I've shown two different cases. In one case, I've shown you that the number of calls required to travel to find the shortest path are more in BFS as compared to Dijkstra. So in your all the cases, Dijkstra will take less number of calls to find the shortest path as compared to the BFS. Okay, when it's compared comes to a weighted graph. If you are calculating number of edges, then it's a different thing. Okay, so that is also need to be cleared. So I think I have explained that thing, and I need to just write a simple code, and this code would act as a template that I will just use in all other problems of this task algorithm that I would be solving. Okay, the first thing first, I have times that says that these two nodes are connected. There's an edge from node 2 to node 1, and there's a cost. Okay, so first thing first, just create an unordered map. Unordered map, we have int, and then we can have a vector pair int comma int, and just call it mp. Okay, now what I will do is travel this times for auto. We can just call it vec. That would go in times, and what it will do is it will take int u, that is vec 0, int v, that is vec 1, and int w, that is vec 2. Okay, great. Now what I need to do in my adjacency matrix, okay, sorry, MP matrix that I've created, I have node u. For that node u, push back what? The distance and the node, that is v and w. Okay, great. Now we have created a adjacency matrix with cost. This is a matrix with cost. Let's name it matrix with cost. Okay, now from here onwards, what I need to do is take a priority queue. Okay, so PRIORITY priority QUEE priority queue. We have a pair. Why I need a pair? Because we are dealing with priority queue, and we need to store the weight as well as the edge that we are traveling to. Okay, so where int comma int, and what next, that is vector where int comma int. Now next thing next, that is greater. Now this is a way we use priority queue in C++. You could have your own way in Java, Python, or any other language that you are using, but this is how we do in C++. Okay, so this is priority queue ready. Now what I need to do is push the first node. But before I do that, I need a vector for storing the distance. Vector int, just say distance. Okay, this is distance. And we have n nodes. And what would be the distance to reach every node currently? That is int max. We want to minimize it, so just initialize it with int max. Okay, now what will be happening is distance. Okay, so distance to reach node k is what? 0. And pq dot push, we have distance and the node. Distance to reach here, the node. Okay, let's just do it n plus 1 using n plus 1 because we are one we are using one based indexing in this particular problem. Okay, okay, now what will happen is while not pq.empty, simple code. I think typos. We have a priority queue. Now what I need to do is d is equal to pq dot top dot first. This is the distance traveled so far. And we can call it node or something like that. Let's just call it node. We have pq dot top dot second node. Nothing else required to describe about it. Now what I need to do is pop this first thing first. That is the first thing. Now I pop this particular out of my queue. Now what I need to do is move to the adjacency matrix of this particular node. So for that I have for auto, you can call it x, and where I will be going, we'll be using mp of my node to reach the next node. Okay, so what is the cost to reach the next node? So just let's find out the next node. Int u is equal to x dot first. Okay, so this is the next node. This is the next node. Okay, I'm not would be getting a compilation error if not see. Okay, next node, and int cost, let's say, would be x dot second. Okay, now what? uh, I have this. Now what I need to do is check whether that this is the shortest path to reach my current node or not. To reach node u, we need to update the distance traveled to reach node u. Okay, so for that I can do is if d plus cost is less than what I've declared it, distance, right? Distance to reach u, then do what is to simply update, that is distance of u would be becoming d plus cost, and there's one more thing. pq dot push my what is to be pushed, distance to reach node u comma node u itself. Okay, great. Now what? We have traversed our matrix, find we have traversed our graph. Now what I need to do is find the best answer. Int answer is equal to int max, that is my minimum time, so that's why I'm initializing it as int max. Now for int is equal to 1 dot I is less than, okay, sorry, I is less than equal to n, because we are dealing with n plus 1 matrix, that's why is equal to less than n. Answer would be max of answer comma uh, what it is distance. Okay, we have distance and it is I. Okay, apart from that we have, now there's one more thing. Since there's also a condition, we will send a signal from node given k, return the minimum time it would take from node n to receive the signal. If it is possible for all nodes to receive the signal, else return -1. So if the answer is not updated from int max, then there was a node that could have that we were not able to reach from our node k. So that's why we would return -1. So we will just check return answer is equal to int max. If it is still int max, then we were not able to find a path to reach all nodes. Then just -1. Okay, else return the answer. Okay, I wish to work it. Okay, I guess it should work according to me. Okay, let's just try to see whether it works or not. If there's some compilation error, some okay compilation error. Where? Unordered. Okay, what is the issue? Unordered map. Int comma vector pair int. Okay, what about closing the map also? Sorry about that. Let's see how many compilation error we can get the answer. Okay, I missed one more. Okay, moving forward. Okay, I have done it too fast. So let's just check for ourselves whether we have made some more errors. I don't see so far. Let's see what will happen. Okay, we got wrong answer. Why we are getting wrong answer? In which particular case we are getting wrong answer? Output is -1 when it should be 2. So I guess the matrix was not updated well. Answer is still -1 in this particular case, and it is -1. So answer is coming -1. Okay, that is the issue. If answer is -1, so what is the problem? I am taking max. Okay, right. Since I am taking max, that is the issue, and I have declared it as int max. That is the issue. It should be int main, because answer should be int main. Okay, then this will again still fall, because I have to make it int main again here also. So now let's try to see whether it works or not. Okay, still we get the wrong answer. Oh, good. It is a quite a long value that we are getting. Why so? Why so? Now we are getting 21478. Okay. Why so? We have distance and what we are doing wrong. Let's go from start. We have an ordered map, and what we do is change into a matrix. That's good. I have a priority queue, and what I do is create a distance matrix, that is n plus 1 comment max. Distance to reach node k is 0, and I'm starting from node 0. Then what will be happening? We need to start from node k, not node 0. Okay, we are getting one more wrong answer. In this case, the answer is right. Here it is also right, but here it should be uh, -1, and I am returning something else. Okay, let's see what is wrong here. Okay. Da, 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 da. If answer is equal to int max. Okay, this would be int max because we are traveling on the distance vector. So if the distance vector, we will be finding the max, and if some node is not updated or was not reachable, that node distance would be int max. So then we need to check this particular condition. Hmm. Again, a compilation error has taken place. Okay, I need to put a ternary operator here. It should work. Okay, this is working. Let's try to submit this. Let's see what happens. Okay, so we were able to submit it with some compilation error and little confusion. Apart from that, we were able to solve this particular problem. It is a easy Dijkstra algorithm problem, and we will move to the next problem. Okay, so let's just erase our current graph and let's see what is the next problem that we have. Minimum cost to make, minimum obstacle, path with minimum effort, path with maximum probability, shortest distance, shortest. Okay, let's go from here to here. Okay, minimum cost to convert a string, right? This is the next problem that we are going to solve. Okay, you are given two zero index strings, source and target, both of length n and consisting of lowercase English letter. You are also given two zero index character arrays, original and change, and integer cost, where cost I represent the cost of changing the character original I to the character I. So it is technically mapping original I to changed I with at a cost of whatever the cost it may be. So it is creating a directed edge from node. So we can just say there's an edge from node A to B at a cost of 2, right? So that is something like that. Where cost I represent, you start with the string source in one operation. You can pick a character X from a string and change it to character Y at a cost of Z. If there exists an index j such that cost j is equal to z, original j is equal to x, and change j is equal to y. Okay. Return the minimum cost to convert the string source to string target using any number of preparation. If it possible to convert source to target, if it is impossible to convert source to target, return -1. Note, there may exist indexes I and j such that original j is equal to original I and change j is equal to changed I. Okay. So what we are doing is we are mapping. Okay, so not mapping, we are creating a graph. First thing first, we are creating a graph. So here we have an edge from node A to node B, a directed edge. Okay, so it would look like something like this. This is my node A, and then there's an edge to node B at a cost of 2. Okay, that is simple. Now what I need to do is we have a string A, B, C, D, and I need to convert this string, each character, to A, C, B, E. And the cost to convert this particular string original to this new string changed should be the minimum. Okay, and how it would be minimum, since because we want to convert the characters from one character to another. For example, here we have node A and we have here to okay, this is what it looks like for node A comma A. From node A to A, the cost would be 0. There's no change required. But from B, we want to reach C. Now let's see in our is there an H from B to C? We have an H from B to C at 5, right? Is there any better H? Change the value index B to C at a cost of 5. Okay, so this was an H from B to C. Okay, great. From node C, we need to convert it to node B. Is there any H from node C to B? Well, we have an H from node C to B. Change value at index. It was supposed to change the value at index 2 from C to E at a cost of 1. change the value at index 2 from E to B. Okay, so this is the Dijkstra part. We go from C to E, then E to B. We could have directly gone from C to B, but it would have costed us 5. But here it is only costing us 3. So this is the part of Dijkstra. Now the issue in this particular thing is that we need to run Dijkstra for each character. We would be running this cast algorithm for each character, not just one. We would be doing it for every character in this particular source. And from that particular character, we would find the shortest distance to all other characters in the particular matrix or graph that are available to us. Okay, so that is a thing. But what would be I sending itself? I would be sending it. What is the mapping of the particular character? Well, each character can reach other 26 character or other 25 characters. The distance to reach itself would be 0, so other 25 characters. Well, I can just create a vector 26 character, and those characters which are reachable from that particular character would update their distance to minimum, and then I have to do this cast algorithm for every character of source. Right, right. I need to do this for every character source. But if I do that in a way, so if I for A I would have to maintain one vector, for B I would have to maintain one vector, for C. So instead of doing that, I think I would prefer to use a matrix that would be doing the job for me. So what can happen is I can have something like this, and here especially, and what is it was A B C, right? It was A B C D. Okay, so this is A, this is B, this is C, this is D, and here we have from node A to node Z, and it will store distance. So whenever I run a Dijkstra for one character, I would send its complete row as a distance vector. So my distance vector would get updated, and I would need to maintain several distance vector, and the task would be done in a single matrix. So when it comes to update B, so the distance from node B to every other node would be updated in this B row, and then similarly in this C row, and then in this D row. Okay, so that's pretty simple, but the part is to work on it. That is, so first thing first, let's just create a graph. The very first thing is to create a graph. We would need unordered map. Okay, RDERORDERED, unordered map, and then we have a character, and then we are mapping that particular character to another character, right? We have vector pair, and then we have a character, and then we have an int to store that. Okay, let's call it mp. What I will do is for int I is equal to 0 dot I is less than n dot I plus plus. Well, is the n given to us? I need to find n. Okay, I guess I need to find n, right? Okay, so int n would be, what is the size originally say? Original dot size. Okay, great. We have original dot size. Now what I need to do in my MP for the current character, that is what I'm doing as for original. Uh, well, original as an array, right? Yes, original as an array. I was getting confused between a string and that thing. Original I dot push back, that is changed I comma cost I. Okay, great. We have a graph structure ready for us. Now what I need to do is a traversal of this cast algorithm for every character in the string. For int I is equal to 0 dot I is less than source dot size. dot I plus plus, and that is I need to do is pick the char ch at every source and source I, right? uh, okay, I've messed it up quite a lot. Yes. No, 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 no. Okay, just close this particular bracket. Okay, now it looks well and good. Okay, now what? We have stored the character source I. Now what I need to do is run a Dijkstra algorithm, right? And I have not created the cost matrix, right? So I also need to create a matrix that would be cost matrix. As I explained the structure, I would need it to store the distance. So vector vector int uh, long long. There's just long long since we are using long long. Would be long long. Let's call it cost. It would be a very big name. So let's just call it cost. And it would have how many? 26. And then we have again vector long long, sorry, long long, and then it would have 26 comma, okay, 26 comma int max here. Okay, great. This is the basic initialization part. Now what I need to do is run a Dijkstra. Okay, so what I can do is do a Dijkstra over there only, but it would be better to separate it as a function. So it will be a void type because I am not returning anything. I just have to update the my cost matrix, right? So Dijkstra, and what we have is the node initially that where I will be going. So char source. Okay, we have source, and then what? We have our graph, so we have to pass the graph dot map. It is holding char, and then it holds a vector that holds a pair inside it. That is a char and integer pair, and it is also called MP. Apart from that, I have a cost matrix that is a vector of vector and long long. It is a vector of long long, and it is called cost. Apart from that, I don't think that I need anything else. If I would require anything, I would just update it. Okay, I was missing one thing, that is this MP was not closed well. Apart from that, everything is closed well. Right? Right. Okay. Now let's do first thing first. That is car. We have an ordered map, and we have our cost matrix. What I need to do is push my current node and update the distance in that. So let's create a priority queue. QUE QUE UE QUE UE. Okay. Sometimes I am so confused regarding this particular spelling. I can't explain. Int, I have char. Okay, great. Now what I have is a comma, and then I have a vector, and vector is having int comma char. Okay, well, it is a pair, so it is having a pair int comma char in itself. Okay, now what? We have a greater that would also have a pair that would be int comma char. Now, since we have closed this, we have priority queue ready. Uh, this is my priority queue that is ready. Okay, somehow I feel like I've made some error because of this particular green font style. Vector, pair, char, int, command, map, vector, vector, long, long, cost. Okay, so I feel that I've done right. PQ dot push. What I would be pushing is node distance read node. That is my source. Okay, and we have cost, right? So what is the cost and what is the current row? We need to do that also. So since we are currently standing at our own cell, the cost would be 0. Apart from that, the cost would be updated. So what I will do is now go to while not pq dot empty. Now even if I copy paste the previous code that I just wrote, it would work here, right? But I have to type it so that it becomes a muscle memory. pq dot top dot first int node, sorry, we have a character, right? Char node is pq dot top dot second. Okay, great. Not second, it will have no bracket. Okay, now what I need to do is pq.pop. First thing first, pq.pop, and then traverse. Go to the adjacent part for auto x. That would go to the MP of my current node, and it will get int d. That would be the distance. Okay, we have d already, so let's just call it cost. So no, cost is already there. Mm, just call it distance. Is there any distance? No, there is no distance. In distance has it dot second, and we have int n. No, let's say adj. That is it dot first. Great. We have it dot second. We have it dot first. Now what I need to do is check whether my cost of uh, what I am having is a source node, right? We have a source A and we have ADJ, right? So it is ADJ minus A. Okay, ADJ minus A is greater than we have D plus distance. Okay, D plus distance. Great. Now what? Then do one thing, that is just update it. Source source minus A bracket ADJ minus A is equal to D plus distance. And the next thing is to push it in a priority queue. So here it goes in the priority queue, pk.push. I'm currently standing at the node ADJ and the updating distance is D plus this. Sometimes I type so wrong that I don't even believe that I have a good day. Now finally what I can do is just give a return statement here. It is not necessary to give this, but I am just giving it out of courtesy. And apart from that, let's call this class right here. So not make spelling errors. Let's just copy it. Okay. I have this class. I want to start it from ch, and I will be passing mp and also the cost matrix. So the cost, not cost matrix, but cost. Cost matrix is too long to type. Okay, so far it feels well and good to me. Now what I need to do is find the best answer. Well, this particular thing I have already done this. Okay, now what is, let's just create a long answer that would be 0 initially, and for int I is equal to 0 dot I is less than source length, that is n dot I plus plus. Source length is I, right? N, right? I have, or I made some original size. Okay, so I need to change it. Source dot size dot I plus plus. Do one thing, that is if so source of I is equal to target I, then do one thing. That one thing is continue, because there is nothing to do. Well, you can add a zero, but there's no point of doing that. If cost of source I minus A and target I minus A is equal to int max, I mean to say we can't just reach there anyway, then just do one thing, that is return minus 1. I mean to say there's no feasible solution existing for this. Now, apart from this, there is one thing that could be done, that is answer plus cost of, so again source I minus A and target I minus A. Okay, great. Now, next thing is to return the answer and see how many compilation errors I have made so far. Because this particular code feels like a jacked one with a lot of compilation errors. And I said there would be compilation error here only. And where I made the compilation error, I have to see for it. Uh-huh. I have a vector, I have a pair, and I create a map. It's saying this vector pair is an error part. Okay, so this vector pair is an error part. Okay, where I made the error, I have a character. And why is there a this particular arrow before that? Now let's try to run this. Now I have an error here. What is the issue? IT, why I'm calling it as IT? Okay, so sometimes just my mind wraps and pushes the code. Da, 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 da. Compilation error. Again, the same issue. Let's try to run this. Again, a compilation error where cost. What is the issue? Vector long, vector long. So, what is the issue, mate? What is the issue? Here you can cost a different type vector. Okay, so they have already defined cost, right? So let's just change it to cost t. Just change it to cost t. And where else I've used cost? Change it to cost t. Just change it to cost t. Anywhere else where I've used cost? Let's just try to run and if we see any error regarding cost t, then okay. Somewhere I've used cost. It should be cost t. Yeah, no. Okay, again I have some error. What is the issue? Okay, this bracket is not closed. I'm sure. I told you there would be tons of this compilation error in this particular code. It was a jacked one filled with compilation errors. Tons and tons of compilation error. What is the issue now? It should be cost t, and it should be cost t. Okay, now I get errors. The cost is coming 28. Here it is coming -1. This one is showing -1. This one is showing. Okay. Sometimes I just feel so doomed, where I made the mistake to this particular question. Let's go from top to bottom. I have a priority queue. Okay, that is good. I have a zero. I push my source. On priority queue empty, I just pick the top and the bottom. I go to distance as it dot second, and then I get adjacent at it first. Cost, if current cost is greater than d plus distance, then update it d plus cost, and then push pq dot push. Okay, so pq dot push is having an error. Uh-huh. Yes, remove this, uh, comma a d j. Now let's try to run this. Okay, it works. It works. It works. We were able to solve this with lots of compilation error. Well, that is supposed to be happening. Okay, two problems down, and what I can see on my screen, there are six tabs more open. I need to do this. I need to push past my limit. I need to push past my limit. Okay. This one looks pretty tough, huh? Minimum cost to make at least one valid path in a grade. Okay, just getting started. I'm just getting started. Guys, I need a water break. Just one water break will do the job for me. Uh, One water break will do the job for me. Water break will do the job for me. Okay, let's return to this particular problem that we were solving, that is minimum cost to make at least one valid path in a grid. Given an n cross n grid, each cell of the grid has sign pointing to the next cell you should visit. If you are currently in the cell, the sign of the grid ij can be 1, go to the right cell, 2, go to the left, 3, go to lower, 4, go to upper cell. Notice that there could be some signs on the cell on the grid that point outside the grid. You will initially start at the upper left cell 0, 0, and valid path in the grid is a path that starts from the upper left cell and ends at the bottom right cell m minus 1 n minus 1, following the sign on the grid. The valid path does not have to be shortest. Okay, you can modify the sign on the cell with cost 1. You can modify the sign on a cell only one time. Return the minimum cost to make the grid have at least one valid path. Okay, I'm standing here and there are a lot of these arrows, and I would move in the arrow direction. Now I need to change the direction of these arrows so that I can reach to the bottom right cell. But I have to do with this return the minimum cost to make the grid have at least one valid path, because every time I turn or change one arrow direction, it costs me one or 1 rupees, I can say, or it costs me one. Okay, so what I need to do is turn these arrows in such a way that I can reach to the bottom right cell at minimum. Okay, so I can start here, and then for every cell I go to that cell, to the next cell, into the next cell, into the next cell. Now if I'm going out of bound, I would change the direction. It will go to next cell, next cell, next cell, and then I change the direction again. That would be 2 so far. Then I go here, 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 and that is 3. You will start from point 0 and to the point is follow 0 to 0 1 0 to 0 3 and 0 3 change the arrow to down. Okay, so this was the one. Here I will go 0 0. It is 0. But here, what is the cost? I go here, then it will go come here. So which one to change? Initially, what I was thinking is that if the last cell that we are going to encounter in the column is pointing me out of the grid, I will turn it down so that I can reach downwards. Because if I'm going in this particular direction, then I want the last cell to point downwards so that I can move to the next lower level row closer to my answer. But here, if I come go from here to here, if I go from here to here, then there is an issue. I need to change this, right? But I don't know that I need to change this because it is pointing to the left, or we can say that whenever I come to the last column and if it does not point to the lower direction, then I would change the direction. It could have been said, but it would be just looking at these small cases. There could be a large number of cases where it won't work. Always think that way. So, which is the most optimal direction to pick? So, there could be three different directions to pick. Three different directions to pick. Uh, I'm counting this direction already counted, so that is why I'm saying three different direction to pick. Else there would be four direction that would be changing. And I can do is for every four direction that I change, I would push that change in my queue, and from that push change, I would try to find the maximum answer, minimum answer, because that one change could also lead to a valid path with the minimum change, right? Okay, so without wasting any time, let's try to do this one also. Well. I need a priority queue. First thing first, I need a priority queue. Priority. Priority queue. What will be having? These are the great. I would have the cell and the distance. No, the number of changes that I've done so far. So that would be vector int. Well, I can just store in a vector int also. So just say vector int. Then we have vector vector int. And then we have greater vector int. And am I closing this? No, I'm closing this. This is Friday. Okay. Separate this from this. Okay. Now what I have a party utility. Now what I need to do is have a result also. Call it vector int result. And what would be the size of that result? Well, it is a matrix, so I can have int n is equal to grade dot size, and it is m is equal to grade 0 dot size. Now what I can do is vector int result and have n comma vector int, that is m comma what I will initialize with int max, right? that suits this best. Okay, what I need to do is now pq.push, and what I will be pushing, I will be pushing three things. That is my current coordinates and the number of obstacles seen so far, or the number of changes that I made. Now, result of 0, 0 would be 0 because there's no cost to change. I'm standing there. Now, while not pq dot empty, I have pq dot empty. I have auto called current. That is auto current would be my pq dot top, and as soon as I get at the top of my priority queue, I will just pop it out of the priority queue, and I will check uh, if result of I bracket c is less than I have to get the cost, right. I not got the cost, so I need to get the cost. I need to also get the sales. So incur cost would be current 0, and I have to also get the nodes. When I is equal to cur 1 and int j is equal to cur 2, right. Now what I can have is cost here. Now if my result ij is already less than current cost, then I don't need to make any change, right. Into if I am already able to reach that particular thing, then I don't need to make any changes. Continue. Okay. Now the next thing is I can make change this particular arrow in three directions, right? So for int I is equal to 0 dot I is less than or less than equal to 3 dot I plus plus. I've got the okay, not let's say not let name it I. Can name it to something. Let's change it the name. What should we name it? We can call it dir. Dir is equal to 0 dot dir. It should be dir. Dir is equal to 0. Dir is less than equal to 3 dot dir plus plus. Okay, so I have directions. These are the four directions in which I can rotate my array. These are the four different directions in which I can change the current arrow direction. Okay, great. Now, next. Okay, okay. Apart from that, let's let's get this particular thing started. I am currently having int. Okay, so as you can see, my dog is barking a lot, so that's why I was just pausing the video because I was thinking he would bark, but when he sees me doing lead code and not getting him anything, he barks. He barks at me saying solving lead code. Well, now I was at I, right? I was at I. Now I have I plus tire 0, right? I have tire 0. I have not created tire, right? To create directions also. What is the four direction that I need to travel? I also need to create them, right? Vector, vector, and it is int. It's called it directions. Vector int called directions, and then you have 0 comma 1. You have again 0 comma minus 1. You have minus 1 comma 0, and then you have what, 1 comma 0, right. You have the four directions. Now what I need to do is in J And guys, sorry, this particular question would be the last question. My dog is barking a lot, and I need to go check him out. Some days I have to. Some days you have to do these things as a pet parent. Is greater than zero because we need to make sure that we are not going out of bound. Okay, so I should be greater than zero, and and g should be greater than, okay, not g underscore should be greater than equal to zero, and so okay, I is underscore should be less than n, and Chi underscore should be less than m. Okay, these are the conditions that I need to check. Now I need to get the direction of my grid. Okay, so int grid dir would be grid ij. Now what I need to do is grid ij is the direction that I am currently standing at. Now int dire cost would be what? Direct cost should be what? Yes, try to find it out. We have grid direction, right? Now, if I minus 1 from this, and if it is not equal to direction of I, if it is not equal to direction of I, because these are the three directions that we are moving, upward, lower, and these are the three directions that we are moving. So this is the direction I, and if this direction is not same to that direction, then it would cost me 1, else it would cost me 0. Okay, that is pretty easy. Now apart from that, we got a new cost, that is div cost plus what was the cost that I said it? It was current cost. Okay, current cost. And then what is to do is, if new cost is less than result, and it is less than result, what is the result? I underscore and then g underscore, right? Apart from this, what I need to do is again update it. Result of I underscore and j underscore should be equal to new cost. Okay, so currently as I'm typing, my laptop charger is being chewed out, and I have to type it fast. pq.push, and we have, okay, we have pq.push new cost. Okay, new cost. And apart from that, what I have to push is I underscore and j underscore, right? Now, since it has been pushed, what I need to do is just return final thing. That is return result of what? That is n minus 1 and m minus 1. What was n? It is m. Okay, n minus 1 and then m minus 1. For God's sake, just work in once without compilation errors, or else I would. Okay, there would be tons of it. Okay, there is no comma. First thing first. Okay, this video is getting longer and longer. Again, no comma. Again, just run it again. Mm, this video got quite messed up. From tomorrow onwards, I will record in morning instead of this particular time. What happened? Dire zero. What is the issue with it? Uh, okay, so this is dire zero. Okay, so what I'm doing is I'm doing an error, right? Right. So what I need to do is um, just call it DRIR. I This is DRI, and this is also DRI, and this would also be called DRI, and this would be also called DRI, right? And what I will do is what I'm calling as directions, right? Directions, and do one thing, that is I plus directions. Okay, what is the spelling of direction? I don't want to create any more errors. Okay, current directions. Do one thing, just paste this directions here and just close this in a bracket and do same here. And I guess it shall be working, as much as my logic says it shall be working. Okay, there's one more issue. This is the issue. Sometimes I just make more errors, and that is why you should write code with the spacing, not like mine that is not spaced well. Well, trying to type fast, that is why I'm not giving that much of spacing. And pq dot push spelling error push, and let's see, we have right directions and everything, right? Die. Yes, I guess. Write it. It is giving one wrong answer. Why? It's giving two as answer when the expected output is zero. Okay, this is messed up. Where am I messing up? Where am I messing up? Getting direction, I'm doing great. Minus, I'm doing correct first. Happening causes. Okay, PQ is then pushed. Apart from that, what is the issue? Hmm. Okay, what is the issue, mate? What is the issue? What is the issue, mate? What is the issue? This what is wrong? What is the issue? I'm not able to get it. Where I have mistaked, what I have mistaked. Please tell me, Lord. Please tell me. New course direction. Grid directions. Grid IJ. Oh no, where I made a mistake. I made the main during the initialization part of the matrix. Maybe. Don't know. No, 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 no. According to me, I've done pretty much right. But what is the issue? Okay, let's try to find it out. We have okay matrix. Initialize it right. We have radical for 0 0. Why not radical empty? Result I is less than current cost and just continue. When the direction that could be changed, data the for direction that we try to change. Okay, I try to change that thing. If I it is in 0, yes, it is in 0. And then do one thing, then get the grid IJR. Now direction cost would be, and the new cost would be direction cost plus current cost, right? Okay, new cost is less than the one stored here, then update it with the new cost. We could not push. Okay, I guess it is pretty much right. And then what is the issue? To say it shall be working according to my logic. No, 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 nah, nah. What is the issue? What is the issue? Hmm. Okay, accelerated grid direction -1 to direction I 0 new cost. Uh, how many? Then this is it. So, what is the issue? but it's not working. It should be working. Should be working because it's working for two test cases. Then where have I made the mistake? Have I repeated the direction somehow? 0, comma 1, 0, comma minus 1, minus 1, comma 0, 1, comma 0. Okay. 1, comma 0, 0, comma minus 1, minus 1, comma 0, 1, comma 0. Okay. These are the four directions which I can travel. Mm, it just becomes sometimes hard to find the direction. Right thing. Okay, enough of it. Need to go to GPT. Okay, let's see GPT. What you say about this? Uh, find the error. Okay. Uh, this is the issue. Now you can't have random directions. Now this causes issues. Mate, come on, mate. Okay. I would have not able to debug this particular thing even in 100 years. Who would have thought that directions would have caused the issue? Okay, so far the code works, and my dog is asleep again. So I guess he is asleep, and what I can do is solve this particular problem. That is minimum obstacle removal to reach corner. It is a similar problem to the last one. As I can see, you have to reach start from 0 to 0, reach the lower m minus n. We can only traverse in 0 cell, but if it is a 1 cell, then we have to remove it. Okay. Uh, Sounds pretty similar? Yes, it is pretty similar to the previous one that we just solved. I think even if I copy paste the last solution that I have did, it would work here. It would work here. Well. What can be said apart from doing it? Okay. Let's first thing first read the question. You are given a zero index integer array grid of size m cross n. Each cell has one of the two values. 0 represent an empty cell, 1 represent an obstacle. You can move up, down, left, or right from and to any empty cell. Return the minimum number of obstacles to remove so that you can move from upper left corner to the lower right corner. Okay, simple Dijkstra. I need to have a vector int called directions, and it would be 0 comma 1 0 comma 1 comma 1 comma 0 comma 0 comma minus 1 comma minus 1 0. Okay, so the four direction that I can do. Now I need I already have a grid, so I won't be needing that particular thing, but I need to find the size of the site. 10 is equal to grid dot size. Okay, now the grid size, and m is equal to grid 0 dot size. And next that is priority queue. Priority priority QUEUE priority queue. What I have to hold? I have to hold uh, index and number obstacle remove. I can have it in a vector. I can have it in a vector. I can create a pair from a pair. Well, that pair thing would is something that I won't like. Uh, you wanna try? We can try with pair, and then have a end, then a parent, right? Or we can just have a simple classic old vector. Well, the choice up to you or me. Obviously, I'm doing the code, so the choice is up to me. Vector will hold int. Okay, vector int. Now next we have vector int. Now we have vector int. Apart from that, we have creator, and then we have again vector in that, and we have int, and then my priority is close. Nothing left. Okay. Apart from that, what I need as a result, vector vector int for the result. Okay. What is the size n comma what vector int and m comma int max. Okay. Now what? Do nothing. Just push what 0 comma 0 comma 0. Okay. And in result 0 bracket 0 would be 0. Nothing more, nothing less. Okay. Now what? While not my priority give dot empty. So as far as you can see, the number of problems that I've solved so far is using the same template that I've used in solving the previous problems, and it is working pretty well so far. So this Dijkstra template or the code comes pretty handy if you just know how to work around with it, and you can just solve a lot of problem using this particular code only. And pq.pop. Now what I have is int d as current 0, I is equal to current 1, and j is equal to current 2. Okay, great. Now what? There's something that I need to do, that is to traverse the directions auto there, that will go in directions. And what it will do nothing, just get the directions. Int x is equal to I plus, and it is called there, and we can just call it dir dot first or dir dot second, or we can just call it dir dot 0, and int y is equal to j plus dir dot 1. Sorry, dir 1. Okay, great. Now we have the directions and everything. We have to do one more thing. If x is less than 0 or y is less than 0, not 2, and x is greater than or equal to n, or y is greater than or equal to m, then continue. You can't move forward. Okay, good. Now what next? Just like my previous Dijkstra code, I will just get weight. What is weight? Well, weight is the weight that is required to check what is the current cell, grid x and y. Now, what will happen is, if it is equal to 1, then it would be just 1, else it would be 0. This is the weight. Okay, I mean to say whether it's an obstacle or not. It is a obstacle or not. Okay, great. Now next thing, that is if d plus, I've just named it d, right? Yes, named it d plus cos is result x and y, and do one thing, that is result dot push y push, just result x y would become d plus wt. And one more thing, pq dot push but uh, d plus wt comma x comma y, we have it. And now what I need to do is return result uh, n minus 1 comma m minus 1, and this is what my answer should be, and it should be working as per my guess, or until unless there is no compilation error, the amount of time it is taking. Okay, there is vector spelling error, first compilation error. Okay, now let's see. Again, this compilation error. Okay, now let's see. Da 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 da. pq dot push. No matching member. What happened? Right. To say we push in priority always. What happened? pq dot push. No matching member function to call push. Uh, Made some spelling errors, right? PRIORITYQUEUE vector vector end vector vector end. So store the vector in that vector and then create a vector in that PQ push. What is the issue, mate? Okay, here's the issue. Okay, I was considering that as the issue. Sorry. One more compilation error removed. Let's see whether it works or not. It shall work, it shall work, it shall work. For good luck, and it causes an error. What is the error? There should be the expected output is 0, but my output is 1. Okay, the output is 0 and my output is coming out to be 1. Why? Why? Let's see why. This was simple, this for debugging part. Hmm. Grid XY and everything. RDU, distance result 0, 0. That is good. I push it in my queue, that is good. Get the top IG in directions, and I flash action 0. And I'm going out of bounds, and it's nothing good. Wait, if result is equal to d plus weight. Sometimes all these error do is nothing, just mess with me. No, no, no. What is the issue this time with the code? What the last time thing happened was, damn, yeah, it should be returning 0, and it is returning 1. Hmm. Mm-hmm. Okay, let's go from start. I have a grid. I created a priority queue, and in my priority queue, after my priority queue, I have a result. Okay, great. In my priority queue, I push the nodes. In my result, I push the distance. While not my priority queue is empty, current as the top of the priority queue, pq.pop get the nodes current 0, 1, 2. Auto directions we have I plus direction 0, j plus direction 1. If weight result, we wait. Great. And d plus weight and x comma y, and then return result n minus 1. Guess the code is pretty right. And what is the issue? Yes, we have no other option. Let's see what is the issue. Okay, I repeated the direction twice. Should be minus 1 comma 0 is 1 or small 2 bucks. Miss the whole code. Hmm. Okay, it also worked. So far the particular thing is that our logic is working pretty fine. And guess this would be in for today. It was not a very great ride today. I was already tired, but tried to complete this video, but just kept getting messed up. Okay, well, whatsoever. We will try to get better tomorrow. For today, just stop here.